Minute Man basically does what I do, but with history and archaeology. He makes some quite interesting videos. So when I get informed of someone who's trying to debunk him, I simply had to have a look. Hello all and welcome along to another episode of Tinfoil Tuesday with me, Simon Dan. Thanks very much for joining me. Okay, so on with today's video then, which comes from a channel called Solis. He's a Tesla-loving wannabe historian who claims to have debunked Minute Man. I wanted to see what all the fuss is about, so I made a cuppa, sat back and watched. I was not impressed. The first person you're going to see is Minute Man, and then Solis pops up. Let's have a look.
You guys are not going to believe this. It goes like this. The number for the speed of light is the same coordinates as the pyramids of Giza. Considering this is one of my favorite examples of the collective aneurysm that is pseudo-archaeology, riddle me this.
Riddle me this, Milo.
Now the first part of that video was Minute Man, and he was taking the mickey slightly out of people who think there's something in the fact that the coordinates of the pyramids of Giza match the speed of light. Actually, it's just the latitude of the pyramids of Giza, not the full coordinates.
Did you know that the original meter distance was defined as 1/10,000,000th of the distance from the poles to the equator?
Yes, back in 1791, the French Academy of Sciences defined the meter, and they defined it as 1/10,000,000th of the distance between the equator and the North Pole, along a meridian that went through Paris. But that actual measured value turned out to be quite off. By 1889, we'd replaced it with a platinum iridium bar. And now? Well, since 1983, a meter is the distance light travels in 1/299,792,458 of a second. In short, the meter isn't based on Earth anymore. It's based on a fundamental constant of nature.
And that the polar circumference of the Earth is nearly exactly 40 million meters, with 40 million, 8,000 meters.
Now, is Charlie trying to say here that the meter is intrinsically linked to Earth's geometry? If so, we've got a problem, because that match isn't real. It relies on modern GPS coordinates, and a unit, the meter, redefined in 1983.
Yeah, pseudo-archaeology. No, talk about pseudo-physicist. So I wanna point something out here. This is where it gets that these archaeologists who don't understand how the universe works to begin with shouldn't even be resorted to as experts on this matter. Because if you can't understand the sciences of what we have today, you won't be able to understand the sciences of people that you think have less than us.
Archaeologists don't need to understand particle physics. Not when they're dating tools or looking at map settlements, decoding languages or examining building techniques. Are we now gatekeeping who's allowed to talk about pyramids? Archaeologists should apparently now sit down and shut up unless they're qualified in quantum mechanics. Behave, Charlie. Let's be clear here. If people in the past had less, then modern archaeologists with more tools and knowledge and data are absolutely the right people to study them.
If we're going to just assume they had less. But, you know, let's do some math here, actually. Let's do some math here. So I find it interesting that you think
The entire fucking universe used the metric system while America's still using imperial. Do you not think that the aliens that built the pyramids would have used something else?
I think Minute Man was being slightly sarcastic here, Charlie. He's basically saying, would ancient cosmic beings, or even Egyptians for that matter, be like, yes, let's encode the exact value of the speed of light, but only in a unit system that France kind of guessed in 1790, then redefined based in light in 1983, and the Americans still actively avoid. And you have to admit, he has a point.
who? No, the Egyptians had the foot long before everyone else. The Romans had a foot, and the Greeks also had a foot. The Roman foot is 2.96 meters. The Egyptian foot, this is kind of weird. How is the Egyptian foot exactly 0.3 meters? It's exactly 30 centimeters?
No ancient Egyptian source says it's exactly 30 centimetres. No modern academic source says that either. The 30 centimetre value is just rough, not exact.
That's kind of weird. Why, if they were such widely created units, you would think that there would be more decimal places there to have to make them line up. Let's just assume you're right, Milo. Okay, let's think this through. Just do this experiment real fast here. If it's just so outrageous and outlandish that these people had any kind of science, let's find the relevant period of a photon that is the wavelength of an Egyptian foot.
So Charlie's now matching photon wavelengths to arbitrary historical units. Why would you even do that? There's no need at all. The funny thing is though, of course, that if I dig hard enough, I can find a frequency where your waistline matches the resonance of a toaster. It's meaningless, but there you go. And by the way, no one is saying that Egyptians didn't have any kind of science. Far from it. We are just saying they knew nothing of the wavelength of light.
The period is 1 divided by the frequency. So what we do is we take the distance and divide it by the speed of light. You get meters to cancel out. You get 1 second. That'll give you your period. To get the frequency, you invert it.
So let me get this straight. You put a distance where the 1 should be, and a speed where the frequency should be, and got an answer in seconds which you believe should be a period. For what exactly? Buddy, if I divide my shoe size by the rotational velocity of Saturn and get 3.2, I don't go shouting saying that proves something. I just realise I've done some nonsense maths and move on. To be clear, you can't just throw values willy-nilly into wave equations without defining a medium, a context, or any sort of physical process.
Let's look at the period here. What is this? Oh my, wow! Almost exactly 1 nanosecond. Whoa, that's pretty odd. That's what a weird coincidence for that to be.
Let's clarify what's actually happening here. He's taken 30 centimeters, a rounded off Egyptian foot, divided it by c, the speed of light, and got 1 nanosecond. Great. So what Charlie's really saying here is, between the dramatic pauses and fake astonishment, is this. Maybe, just maybe, the ancient Egyptians encoded the speed of light into their measurements. The thing is, the Egyptian foot isn't even a real unit. It's a modern retrofitting of ancient measures like the cubit.
Let's check one of these other ones. What are the rest of these? Let's go through this kind of quickly. Royal cubit, the accepted version is 0.525 meters. Oh, wow, look at that. But then there's also the 0.523. They both straddle 1.75 nanosecond. What do you know? Oh my God, what a coincidence.
I'm going to try some of this. Oh wow, look at that. A royal cubit of 52.5 centimeters divided by the speed of light gives you, wait for it, 1.75 nanoseconds. Yeah, I can see how he likes that.
Small cubit at 45 centimeters. Oh my God, 1.5 nanoseconds. Oh, what? The shoulder neck's at 37.5 centimeters. Whoa, look at that, 1.25 nanoseconds. Okay, I'll give you this one, the great span at 26 centimeters. Doesn't come out very nice, 8.67. It's really close to 8.66 repeated, so just hold on, we got more.
Yeah, he's just like, ignore.
Small span at 22.5 centimeters, 0.75 nanoseconds. The double hand at 15 centimeters, look at that, it's 0.5 nanoseconds. The fist at 11.25 centimeters, 0.375 nanoseconds. Another one that's not as pleasing, but got the hand at 9.375 centimeters, comes in at 0.3127 nanoseconds. Again, not okay. All right, back to the palm. We're at 7.5 centimeters, coming in at 0.25 nanoseconds. And we got the finger at 1.875, comes in at 0.0625.
Great, well done you. Excellent ignoring skills there on the two that meant nothing.
Now look at this. It doesn't seem like there's much of a trend here, but if you look at all these periods, I'm going to go through it. 0.0625, then 0.25, then 0.3127, and this is where it gets better. 0.375, then 0.5, then 0.75, then 0.875, then you've got one nanosecond, then 1.25 nanoseconds, 1.5 nanoseconds, 1.75 nanoseconds, and 2 nanoseconds. If we even go a little bit further, we're going to look at the rod, which is 100 cubits, and then the league, which is 20,000 cubits, we got 1.75 and 3.5. See this trend here? That's pretty odd, isn't it? What a coincidence.
Well, yes it is. You could do this with Lego bricks, banana lengths, or the average height of a llama, and still find a trend if you cherry pick the results.
This gets even cooler, because if you take a look at the frequency for each of these, Wow, look at this. And now it's just slightly off, and you can see I put the frequency and then like what the easy rounding is, because you can see these carry digits. You basically got 1.6, then 4.0, then 3.2, then 2.666, then it's almost exactly 2, then 1.33, and then 1.14. Okay, it's not the greatest. Then you got 9.99, which is almost exactly 1. Then you got 7.99, it's almost exactly 8. Then you got 6.666, yeah. Then you got 5.71, by 5.7 essentially. And then you got 4.99, which comes to 5. The bigger ones too come out to 5.7 and 2.86. That's not the great, it's okay though. But this is just the speed of light in a vacuum.
But that's not a frequency in the way that we know frequency. You've got your made up number from earlier, using the incorrect inputs, and then figured out what a frequency is using an equation. It means absolutely nothing, Charlie.
So this is what it'll be for a photon of these lengths, the frequency and period in a vacuum. That's really, come on, that's not a coincidence, but okay, let's just accept maybe it's a coincidence. Let's check what it is when it's the speed of light in air, not just the speed of light in vacuum. It's really close, so I'm not even going to go through them all. You can see it's basically the same. It's a little bit lower, a little bit off from it. This is where it gets really cool. Are you ready for this? Are you ready for this? Nudie here again. I'm not wearing glasses. But look at this. Do you see this? Come on. Like, it's not even just the period is nice, but the frequencies are so clean. Literally 8.3 repeated, 3.3 repeated, 4.16 repeated, 5.0, 6.66666666.
I'm sorry, but I can't watch him reading out numbers like they mean something anymore. Back to Minuteman.
Say, whoa, well, how'd the Egyptians figure out what the speed of light was?
How did we measure it, dude? Like, what are you talking about, man?
We measured it first in 1676. Ole Roma noticed that the timing of Jupiter's moon Io varied depending on Earth's position in its orbit. He correctly deduced that light takes time to travel, and the delay was due to Earth being further away from Jupiter at some times.
And that would be very astute of you. Secondly, the thing that I think is even more shocking about this is the implication that ancient Egyptians used the metric system.
And yes, for the rest of the video, Charlie puts up all his images, including his cruddy table as Minuteman talks. Absolutely hilarious. What an odd debunking that was, hey people? Well, there we go everyone. What do we think of Charlie Solis there and his debunking of Mini Minuteman? Let me know in the comments below. We're all wrapped up. As I say, we're all done and dusted for another one. Thanks so much for watching today. As ever, it's very much appreciated. If you enjoyed it, please do consider subscribing to the channel, hitting the thumbs up button too, and sharing if the feeling takes you. I've been Simon Dan. Have yourselves a great day, and I'll see you tomorrow for episode 7 of Mark Sargent's Flat Earth Clues. See you then.